Hello everyone, welcome to video 1-7, and we are going to be talking about midpoints and bisectors beginning on page 49 in your books. We're going to have three lesson goals for this lesson. Number one is to find the coordinate of a midpoint when you have two endpoints on a number line. Number two is to find the coordinates of the midpoint when you know two endpoints on a coordinate plane, or also to find one of the endpoints if you know an endpoint and the midpoint. And then the third goal is going to be finding missing values using the definition of a segment bisector. Okay, so in this learn section where we're finding midpoints when we know the endpoints on a number line, we can see that a midpoint of a segment is a new vocab word that just means the point that is halfway between the endpoints of the segment. A point is a terminology called equidistant from other points if it's the same distance from them. And the midpoint is going to separate the segments into two segments with a ratio of 1 to 1. In other words, congruent segments. So we're going to use the section formula to derive the midpoint formula. If you recall from lesson 1-5, we talked about if we know one first endpoint on the number line, and when we think about finding halfway down that segment, there's our A over B, and then here is the difference of the endpoints. So if we were to distribute this 1/2 here to both terms, we get x sub 1 for our first term, or 1 sub times x sub 1, plus 1/2 x sub 2 minus 1/2 x sub 1. And if you'll notice, we have two like terms with multipliers times x sub 1. So 1 and then a negative 1/2 becomes a positive 1/2 x sub 1 plus 1/2 x sub 2. And then you can see our ellipsis here to our next slide. We can see where our key concept comes in here. If AB, segment AB, has endpoints given as x sub 1 and x sub 2 on a number line, then the midpoint of AB is going to be found at coordinate m equals x sub 1 plus x sub 2 over 2. And that's the derived formula on that previous slide with just the 1/2 multiplier factored out of both terms. So we can think of this always as the average of the endpoints on the number line. So here we're asked to put the midpoint on a number line key concept into practice in example 1. It says, what is the midpoint of segment XZ? And we can see that X is located at -3 and Z is located at +8. And we want to find out where is the middle of that segment. So here we're going to write the midpoint formula down, as you can see is written in your book first, x1 plus x2 over 2. And in this particular case, it looks like they've made z our x1 and our x2, but it really doesn't matter which one you label which, as long as you are doing the correct operation between, which is adding. Okay, this is a little different than what we were doing before, where we were finding the difference of the endpoints within lesson 1-5 and lesson 1-6. Whenever we find the average, you can always think about that we are adding. That's the operation that we are doing. Regardless, when you substitute those values, you will see that we get 5/2, or we have a second blank you can fill in as 2.5. Go ahead and make that a decimal since it's a terminating decimal. So the midpoint of XZ is 2.5. And so we'll go ahead and plot that point right on the number line. And that certainly does appear to make sense. So turn the page to the top of page 50, and you'll find our first check of this lesson, finding the midpoint on a number line. This time it is the midpoint of segment AF, and use that midpoint formula like we did before and see what you come up with. Take a pause on the video and work this out now. In example 2 on page 50, we're starting to use this idea of the concept of midpoint in an application question. So we have an example of signs here in a vintage clothing store a pony is working in. She wants to hang a new sign so that it is centered above the dressing room doors. So you can see in the picture over here. Given that the dressing room doors have the same width, find the point along the wall that a pony should hang the new sign. So with the measurements applied to this dressing room picture, we can see the left edge of the dressing room doors is 7.5 feet from the corner of the room, and the right edge is 13.5 feet from the corner of the room. So of course, those are the values we see substituted in. And into our midpoint formula, we are going to add, remember, when we're working on the midpoint arithmetic. So we have 7.5 plus 13.5, which is 21 all over 2, or we can simplify that to 10.5 feet. Of course, we want to put that back in the context, the units of the problem. So a pony should hang this sign 10.5 feet from the left side of the wall. Here's a check of another application problem using the idea of midpoint. So this time Jorge is traveling from his school on 38th Street and going to the library on 62nd Street, and he stops halfway there to take a break. We want to know, where does Jorge stop? So we're going to use this midpoint formula applied to this problem. Take a quick pause on the video and work this out and see if you can get it. All right, for our second learning goal at the top of page 51 here, we are going to be talking about how to apply this idea, the key concept of midpoint, to points that are in a segment on the coordinate plane. Notice that there's some scribbling out here I've done. This is the section formula, the part that was just maybe a little bit more complicated than it needed to be in the last two sections, the way your book taught it. We went a little different route, but the most important thing I want you to know is right here at the bottom. And this is, as you can see, I hope, the midpoint formula just applied to one coordinate at a time. So this is the exact same formula we had for just the number line when we had just x values. But now that we're on the coordinate plane, of course, we have an x coordinate and a y coordinate. So we're going to do that same average of values for the y's as well. So here is that formula applied as a key concept for the midpoint formula on the coordinate plane. It says if segment PQ has endpoints at P, which is given as x sub 1, y sub 1, and Q, which is x sub 2, y sub 2, and you can see those labels over here on the diagram, then the midpoint of M has the x and y coordinates that come from x1 plus x2 over 2, or the average of the x's, comma, y1 plus y2 over 2, or the average of the y's. And that's a good thing to kind of write down underneath this formula, the average of x's and comma, the average of the y's. Just a good way to kind of keep it in mind. So using this formula to go through and find the coordinates in example 3 that come out of the midpoint of segment AB, where we're given A's coordinates are -2, 1, and B's coordinates are 8, comma 3. And so our process here is to start by having the midpoint formula written down, remembering that our coordinates were A, -2, comma 1, and B, 8, comma 3. See how these coordinates are pulled into the formula. So we take both of our x coordinates, -2 and 8, and we average them. And -2 plus 8 is 6, of course. Don't forget to take half of that. So we get 3 for our x coordinate. And running down our y's, we're going to take our y coordinates, 1 and 3, and make a new midpoint out of them. So 1 plus 3, divide by 2, or 4 over 2, or 2. And so our final answer is the point 3, 2. Okay, time to check what you know about the midpoint on the coordinate plane with this new example. This time we're finding the coordinates of B, which is the midpoint. So notice it's not always finding the letter M as the name of the midpoint. In this case, it's B, but the formula is derived the same way, x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2, with just some new coordinates to fill in and practice that process. Take a pause on the video now before we move on to our second part of this learning goal, where instead of finding the midpoint, we will be finding an endpoint. All right, I'm on the top of page 52 with example 4. This time we're going to be finding some missing coordinates, but not of the midpoint itself. It says find the coordinates of A if P 3 comma 1 half is the midpoint of AB, and we know that B has coordinates of 8, 3. Okay, so we are going to, if we just do a quick little sketch of what we're doing here, right? So we know how to find this if we have this to begin with. This has always been our problem up to now. Find the midpoint on a number line or in the coordinate plane. But this time, what we're going to start by knowing is we know the midpoint, we know an endpoint, and we're being asked to find the other endpoint. We're going to use the same key concept of midpoint formula, but we're going to use it a little differently. Okay, so you can see that we've started with our midpoint formula written out, as we normally do, right here. And you can see that in place of m, we've put what we know the coordinates of the midpoint are, which in this case is 3 comma 1 half. And then we are going to substitute in what we know about the endpoints. Well, we don't know A, because that's x1, y1, but we do know the coordinates for B, so we can go ahead and substitute that in. Our x coordinate for B is 8, and our y coordinate is 3. So now we can write two equations in order to solve for the missing x1 and y1. So the coordinate that involves x1 is, of course, our equation of the x coordinate from the midpoint, 3, equals x1 plus the x coordinate we know, which is 8, all divided by 2. And as you can see in your book, you're prompted to multiply each side of the equation by 2. We'll go ahead and write that in. And of course, we do that so that the factors of 2 will divide out to 1 on the right-hand side. So we get, to simplify it, 6 equals x sub 1 plus 8. And so our x sub 1 comes out to be negative 2. Then we can write a second equation that involves our y1. So we're going to take our y coordinate from the midpoint, which in this case is 1 half. And the part of the midpoint formula that we didn't have y1, we know is y1 plus 3, the y coordinate of the other endpoint divided by 2. Again, our process is going to be get rid of that fraction by multiplying both sides by 2 and getting one step closer as we simplify to finding that y1 value. In this case, y1 happens to come out to negative 2 as well. So of course, our final answer for the coordinates of A is negative 2, negative 2. It's just a coincidence that those coordinates are the same. Because geometry is a visual math, you can see here we have a continuation slide here where we're taking our answer that we found, negative 2, and we plot that, as well as the point that we knew from the beginning for the other endpoint, 8, 3, and see if that midpoint that we were given to begin with looks like it makes sense, and it certainly does visually. Take a pause in the video to check your understanding of finding missing coordinates that are not the midpoint in this check here at the bottom of page 52. Continuing to our last learning goal at the top of page 53, we're going to be talking about bisectors in this section. Because the midpoint separates a segment into two congruent segments, meaning the distance on one side is the same as the distance on the other, of course, we can say that the midpoint takes an action called bisects the segment. Any segment, line, or plane that bisects a segment by going through that midpoint is called a segment bisector. So again, things that we can measure is a segment, but that segment might have a line come through it, like so. Pretend it goes through that point. And this line, let's say line L, could be considered a segment bisector. We might have a segment come through it like so. And we'll say this is segment AB. Segment AB is also a bisector of that red segment. And we also might have a plane. Now, I'm not going to draw that one to complicate the picture, but you get the idea. Anything that goes through that midpoint is called a segment bisector. So we can use that concept to find some missing values. In example 5, we're asked to find the measure of RT if T is the midpoint of segment RQ. So find the measure of RT if T is the midpoint of RQ. So we can use the idea that T is the midpoint and that therefore the two parts that the midpoint separates the segment into, RT and TQ, are equal. So that's our first prompt, is to go ahead and use that definition of midpoint to equate those two measures. Then to substitute in the expressions for those two measures, 2x plus 3 equals 4x minus 5. And then go ahead and subtract the 2x from either side, simplifying our equation one step further, adding 5 to each side, and then dividing both sides by 2, we get that x in this case is 4. Now again, remember, we want to double check, are we at the end of the problem or are we just at the end of the algebra? In this case, we're just at the end of the algebra because it's asking us to find the value, remember, of RT. So we're going to substitute into the expression for RT the value for x that we just found. And we get 11, my favorite number. So RT equals 11 is our answer here. Use that same idea of example 5 to find the measure of RS here if we know S is the midpoint of RT. Here in example 6, we want to make sure we are using the idea of midpoint to find what it is we're being asked for at the beginning of each problem. This time, though, instead of finding just a part of the segment, we're being asked to find the total length. So it says to find the measure of segment AC, notice that's the full length of the segment, but if we know that B is the midpoint of AC. I also want to remind you about a little bit of notation that we talked about on a diagram. Remember congruent segments, which is what a midpoint divides the segment into, we can use those tick marks to show that those values, their measures, should be the same. So in this case, the definition of midpoint tells us that AB is equal to BC, as we notated on the last slide. The substitution of each one of those expressions for the lengths means that 5x minus 3 is going to get set equal to the other segment length, 2x plus 9. If we go ahead and subtract 2x from each side, notice we will get 3x on the left-hand side, minus 3 is equal to 9. And adding 3 to each side, we get 3x is 12, or x is 4. Now to answer the full question, we're going to take the value we found, x equals 4, and we're going to substitute it into the expression for the full length of AC, which is the sum of AB and BC. So we can put that into the expression 5x minus 3 plus 2x plus 9. And so that's our first line. Substituting in the value we know for x being 4, we get to simplify 20 minus 3 plus 8 plus 9 is going to come out equal to, well, this is 17 and this is another 17, so 34. And just to note here, another way to go about this is instead of putting it into the expression for the full length of the segment, you could also, since you know it's the midpoint, you could substitute that x equals 4 into just one half of the segment and then just multiply it by 2. For instance, if we took just the part for AB, we would say AB is 5 times 4 minus 3, which of course is 17. And since AC is 2 lengths of AB, then we could get 34 that way as well. Really doesn't matter so long as the expression you set up is algebraically and geometrically accurate. For our last check of the video, take a pause here and use the idea as we did with example 6 to find again the measure of AC, the full total length of the segment, if in this diagram we know that B is the midpoint, and round your answer to the nearest tenth if necessary this time. Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching. All right, let's see how we did on our checks. Back on page 50, the check for example 1, to find the midpoint of segment AF, we would say that the midpoint was going to be found by taking the x coordinates or the coordinates on the number line. There's not an x and a y anymore, remember, back here, and just averaging them. So -5 plus 7 all divided by 2 is 2 divided by 2 or 1. So the midpoint of that segment is 1. Then in our application check, Jorge is traveling from the 38th Street to the library on 62nd Street, and he stops partway through his journey. So we will average those two. And of course, we get that that is 100 divided by 2, or his stop is going to be at the number 50, but in the context of the problem, 50th Street. Now in our check for example 3, we're finding the midpoint of the coordinates of B, which is the midpoint of AC. So our B point is found by taking our X coordinates, -3 and 5, and averaging them, and our Y coordinates, -2 and 10, and averaging them, and then just simplifying. So of course we have 2 over 2 and 8 over 2, or that coordinates of B are 1, 4. In our check for example 4, we're going to take the coordinates of the point we're told is the midpoint, which is R, so 6, -1, and set that equal to the midpoint formula with our unknowns for x1 and y1 left in. So x1 plus 12 for the x coordinates average, comma, y1 plus 4 for the y coordinates average. And then remember, we can make two equations out of that. One from the x coordinates and one from the y coordinates. Remember our steps that we used is to multiply both sides by 2 get closer to that y1 and x1 value, because of course we know that will cancel out the fraction part of the midpoint formula, the average piece. So we have 12 equals x1 plus 12. So in this particular case, x1 is 0, and y1 over here, when we multiply by 2, we get that. And when we subtract our 4, we get, so our point for the coordinates of Q, which is the other endpoint, is 0, -6. Always a good idea to just draw a quick sketch of the picture that we end up with. So if R is is 6, -1, that R is going to be right about there. And our S is coordinates 12, 4, like so. Then of course 0, -6 does make sense as the other endpoints. Now we have our variables not applied to coordinates, but applied to expressions for the value of the segments. Check for example 5, it says S is the midpoint of RT, which means that the expressions for RS and ST can be set equal to each other. Subtracting 6x, we get that x, and then adding 5, x is 9. And so our value for RS is going to be 7 times the value 9 we found, all minus 5, or 63 minus 5, or 58. So that would be choice B, of course. And in our last example, we have a similar setup to example 5, where we know B is the midpoint. So these two expressions, 3m plus 4 is equal to 8m plus 7. Subtracting our 3m's from both sides, we get 5m. Subtracting 7 from both sides, we get -3. So our m is equal to -3/5. It said round to the nearest tenth, so it's okay if you'd like to at this point to make that into a decimal, which is -0.6. And then we will go ahead and substitute that in to find the full length of AC. So 3 times -0.6 plus 4 plus full length, remember, 8 times -0.6, all plus 7. And when you do the arithmetic out on that, you should get that AC, which is what this is the expression for, forgot to label that, is positive 4.4. That's it. We'll see you in the practice.